Hi everybody, and welcome to this lesson on looking at the basic building blocks of VPCs or virtual private clouds. So a virtual private cloud is a virtual network dedicated to your AWS account. It's logically isolated from other virtual networks in the AWS cloud, and you can launch your AWS resources such as EC2 instances in your own VPC. Now, when you create a VPC, you must specify a range of IPv4 addresses for the VPC in the form of a class interdomain routing or CIDR block. For example, you guys see 10.0.0/16. This is an example of a CIDR block. Now the diagram that you guys see, it shows a VPC with an IP4 CIDR block and the main routing table. The VPC spans all availability zones in the region. After creating a VPC, you can add one or more subnets in each AZ. When you create a subnet, you can specify a sitter block for the subnet, which is a subset of the VPC sitter block. Each subnet must reside entirely within one availability zone and cannot span multiple zones. Availability zones are distinct locations that are engineered to be isolated from failures in other availability zones. And by launching instances in separate availability zones, you can protect your applications from the failure of a single location. So in this diagram, you see a VPC that has been configured with subnets in multiple AZs. So we have 4 subnets, 1A, 1B, 2A, and 3A. Now an IPv6 sitter block is associated with the VPC, and an IPv6 sitter block is associated with subnet 1. An internet gateway enables communications over the internet, and a VPN connection enables communication with your corporate network. If a subnet's traffic is routed to an internet gateway, the subnet is known as a public subnet. So in this diagram, subnet 1 is a public subnet. If you want your instance in a public subnet to communicate with the internet over IPv4, it must have an public IPv4 address or an elastic IP address. If you want your instance in the public subnet to communicate with the internet over IPv6, it must have an IPv6 address, because by default all IPv6 addresses are public. Now if a subnet does not have a route to the internet gateway, the subnet is known as a private subnet. And in this diagram, subnet 2 is such a subnet. Now if a subnet does not have a route to the internet gateway but has its traffic routed to a virtual private gateway for a VPN connection, the subnet is known as a VPN-only subnet. So in this diagram, subnet 3 is a VPN-only subnet. And currently, just keep in mind that AWS does not support IPv6 traffic over a VPN connection. So in the Amazon VPC, each EC2 instance has a default network interface that's assigned a primary private IP address on the VPC network. You can create and attach additional elastic network interfaces, or ENIs, to any EC2 instance in your VPC. Each ENI has its own MAC address. It can have multiple private IP addresses, and it can be assigned to a specific security group. The total number of supported ENIs and private addresses per instance depends on the instance type. The ENIs can be created in different subnets within the same availability zone and attached to a single instance to build, for example, a low-cost management network or a network and security appliances. Now you can set up your VPC subnet as a public, private, or VPN only like we saw before. Now in order to set up a public subnet, you have to configure its routing table so that traffic from that subnet to the internet is routed through an internet gateway associated with a VPC. By assigning an EIP address to instances in that subnet, you can make them reachable from the internet as well. Now it's always best practice to restrict both ingress and egress traffic for these instances by leveraging stateful security group rules for your instances. Stateless network filtering can also be applied for each subnet by setting up network access control lists for each subnet. And we will look at security groups and network access control lists in another lesson. Now for private subnets, traffic to the internet can be routed through a special network address translation or NAT instance with a public EIP, which resides in a public subnet. This configuration allows your resources in a private subnet to connect outbound traffic to the internet without allocating elastic IP addresses or accepting direct inbound connections. AWS provides a pre-configured NAT server image, or you can use custom AMIs that support network address translation. So this figure basically shows an example of a VPC with both public and private subnets by using an internet gateway. Now finally, by attaching a virtual private gateway to your VPC, you can create a VPN connection between your VPC and your own data center. The VPN connection uses industry standard IPsec tunnels to mutually authenticate each gateway and to protect against eavesdropping or tampering while your data is in transit. Now for redundancy, each VPN connection has 2 tunnels, with each tunnel using a unique virtual private gateway public IP address. Now there are 2 different routing options for setting up a VPN connection. There's the border gateway protocol for static routing, and for that you need the IP address and the BGP autonomous system number or ASN of the customer gateway before attaching it to the VPC. And then you can also use the AWS Direct Connect to establish a private logical connection from your on-prem network directly to your Amazon VPC. The Direct Connect provides a private high bandwidth network connection between your network and your VPC. Now you can use multiple logical connections to establish private connectivity to multiple VPCs while maintaining network isolation. And with Direct Connect, you can establish either a 1 gig or a 10 gig dedicated network connections between AWS and any of the AWS Direct Connect locations. And finally, you may combine all of these different options in any combination that make the most sense for your business and security policies. For example, you can attach a VPC to your existing data center with a virtual private gateway and set up an additional public subnet to connect to other AWS services that do not run within the VPC, such as an Amazon S3 bucket. Amazon SQS or Amazon Simple Notification Service. In this situation, you could also leverage the IAM roles for EC2 for accessing these services and configure IAM policies to only allow access from the elastic IP address of the NAT server. Now in the beginning, we looked at something called sitter. Now I briefly mentioned it and it's something that's required, but before ending, I just wanted to briefly give you an overview about what is sitter or classless interdomain routing. It's basically an IP addressing scheme that improves the allocation of IP addresses. It replaces the old system based on Class A, Class B, or Class C. This scheme also helped greatly extend the life of IPv4 as well as slow the growth of routing tables. So in the old method of IP addressing came with inefficiencies and exhausted the availability of IPv4 addresses faster than anybody thought. So the classful routing system included 3 classes, A, B, and C. Class A had over 16 million host identifiers, Class B had 65,000 and odd, and Class C had 254. Now the problem would commonly occur when an organization required more than 254 host machines and therefore could no longer fall into Class C but rather Class B, which jumped about 65,000 addresses. So basically this meant that organizations were wasting a lot of IP addresses when they only needed to use a few. So with sitter you can define prefixes of arbitrary lengths, making it much more efficient than the old system. The sitter IP addresses are composed of 2 sets of numbers. The network address is written as a prefix, like a normal IP address, and the second part is a suffix which indicates how many bits are in the entire address. For example, /12, /18, /24. Now I suggest you guys go ahead and go on Google, and there are a few tables, and I've also included that in one of my handouts, that shows you what these prefixes and suffixes mean and how many addresses a /12 would make or a /22 would make. Now you don't need to know all of these specific details for the exam, but just keep in mind what is sitter and it's required for a VPC. So let's go ahead and log into our AWS console and get our first VPC created.